Hey, Algebra 1, Mr. Jorgens here, ready for week 3 of distance learning. We're going to start with section 1.4 of the textbook. It's all about solving absolute value equations. We're going to do this over 2 days, so I'm calling this one part 1. Hopefully you're ready. Take some notes down as you watch. You've probably heard a little bit about absolute value before. That's going to be the main topic that we're focusing on today. In the end, absolute value, all it does is just measures the distance that a value or a point is from 0. And I like thinking about these on a number line. There's definitely some rules that we can do, like it turns the negatives positive, and it keeps the positive, and we'll talk about that in a second. But before we get there, I just want to think of it as measuring the distance from 0. So if I think of a number line, I'm going to center my number line at 0. And carry it out a few points in each direction. If we think about the number 5, 5 would come up over here, right? Because I have my positives to the right and my negatives to the left. So if I have the point 5, the distance that 5 is from 0 is 5. So since that distance is 0, I can say that the absolute value of 5 is 5 because the distance is 5 spaces away from 0. Similarly, if I'm looking at negative 5, that would be right here because it's 5 spaces to the left. If I go to measure the distance that negative 5 is away from 0, it would be 1, 2, 3, 4, 5 spaces. So since negative 5 also has a distance from 0 of 5, its absolute value is also 5. So kind of our rules in general are that if you have any positive number, like for instance, say we have the absolute value of 3, it's just going to stay as whatever the number is, the positive 3. And that's because the number 3, which is right here, is 1, 2, 3 spaces away from 0. So that distance is 3. If we have any negative number, like say we have the absolute value of negative 2, it's going to turn it to positive 2 because that's 2 spaces away from 0. And if we have the absolute value of 0, it's just going to stay as 0 because 0 is exactly on 0. So it's the distance from 0 is 0. It's kind of a quick refresher of what you should have learned about absolute value in your past. We're going to start learning to solve some equations with our next example. Our first example is that the absolute value of x minus 4 is equal to 6. Now, based on what I learned on my last screen, I'm going to know that this inside part could be two different numbers because I know that the absolute value of 6 is 6, and I also know that the absolute value of negative 6 is 6. What that means is that x minus 4, the inside part of my absolute value sign, can be either 6 or negative 6, right? Because either 6 or negative 6 on the inside is going to be equal to 6 once I take the absolute value. So what I'm going to do is I'm actually going to divide my equation into two parts because I know that either x minus 4, the inside part, is equal to 6, or x minus 4, that inside part, is equal to negative 6. What I've done is I've now set myself up with two mini equations that I can solve. My first one, x minus 4 equals 6, is an equation where I'm going to have to undo this subtract 4. Solve that equation really quick. So if we undid the subtract 4 by adding 4, 6 plus 4 makes 10. So my first solution is going to be x equals 10. If I'm at 10, 10 subtract 4 is going to make 6. For my second equation, x subtract 4 equals negative 6, I'm also going to add my 4 over. And I get x equals negative 2, right? Because if I have a plus minus chart, I have 6 negatives and 4 positives, meaning that I have 2 more negative than positive. So my two answers here are 10 and negative 2. And the reason why I have two answers is because there's two possibilities, 6 and negative 6, that would make the original equation have an absolute value of 6. Let's try a second example. This one has an extra piece to it. The absolute value of 3x plus 9 subtract 10 equals negative 4. Again, on this problem, I'm looking to find the numbers that if I plug it in will make the equation true. Now, what's different about this one is this minus 10 part here. And that minus 10 part is going to affect me thinking about the absolute value of negative 4. I want the absolute value piece to be by itself so I can think about it like my last problem where I know it's going to be either 6 or negative 6. In order to move that minus 10 away, I can add it over to the other side to get started. And if I make a plus minus chart, 4 negatives and 10 positives, it's going to make a net result of 6 positive. And then on the left-hand side, I'm just left with the absolute value of 3x plus 9. Now, once I'm here, I know that the inside number here, 3x plus 9, is either equal to 6 or negative 6, right? Because the absolute value of 6 would be 6. The absolute value of negative 6 would also be 6. So I know that either 3x plus 9 equals 6 or 3x plus 9 equals negative 6. And just like example 1, I'm going to have two answers here. Go ahead and solve out my first equation